So yesterday's is up today, and today's will go up today. Anyway, so if we are going to use trig to solve real-world problems, we have to be aware that the real world exists in 3 dimensions, yes? And our paper exists in how many dimensions? What does a drawing on my paper have? 2 dimensions, length and width, right? If I want to measure the height of a mountain in real life, that mountain grows up, doesn't it? Which is a dimension that I cannot draw on paper in reality, yes? So we have invented these words that explain what the real life angles are and the way we draw them on a piece of paper. Everybody cool? All right. Now the first thing we're going to talk about is this, the angle of elevation or the angle of inclination. First of all, you need to be made aware of the fact that these are synonyms. They mean the same thing. Angle of elevation and angle of inclination both mean the same thing. Excuse me. What do they mean? What does the word elevate mean? To go up, right? So an angle of elevation is an angle that goes up. How do I measure an angle? What is needed to make an angle? How many lines? 2. Now, if I draw this angle, don't draw this. Is that an angle? It's got 2 lines, meets at a vertex. Does it have an elevation? Would you argue that one of those lines is going up? Which one? The one on the left or the one on the right? They're both going up, right? So there is not an angle of elevation there. Is everybody cool? All right. Now, if I were to ask you to look up right now, what would you do with your eyes? Exactly. Where did your eyes start? Straight at who? Me. Why? Because I'm gorgeous. No, not really. Because I'm the math teacher. Your eyes are all looking at me. Most of you. Some of you are like, I'm not looking at him when he says that. What a clown. But at some point in the next couple of seconds, you're all going to look at me. That's where your eyes are starting. Now, raise your eyes up. That creates 2 lines, yes? There's the imaginary line from your eye to me. That's where you start. You then look up and create an imaginary line to what you are looking at. Does everybody understand? That is an angle of elevation. Does everybody get that? Yes? Okay, so here's what it looks like. It starts with an eye. Blue eye. Now, if you're like me, you're tired today, so maybe you have some blood in your eyes, because I was up late watching the Jays. The eye starts where? Straight forward, which we call the horizontal. Okay? If you raise your eye and look up, you then create, this is your line of sight. Once you move your line of sight that starts level, hopefully your line of sight is in front of you so you don't walk into a wall, and you move your eyes up, you create this angle. There's your theta. Everybody cool with that? Does everybody understand what is happening there? My eyes have moved up. So this theta becomes an angle of elevation. All right? It is and I'm going to change color. It's the angle between the ground, and I'm going to put ground in quotes. Because by ground, I mean where your eye starts, right? We're not slithering around on our bellies like snakes, yes? Okay, some of you might be. I don't know. I don't know what you do with your free time. But I don't slither around on my belly like a snake. Sometimes I do that breakdancing move, the worm, just for fun, but not very often. I'm getting old. It hurts my back a little. But I can still do it if I need to. If you have a breakdancing emergency, you may call me and I can do the worm if you need me to. Both forwards and backwards, I might add. Anyway, it's the angle between the ground and where you look up. Okay? That is the angle of elevation, which everybody understands. No problem. They get it. Okay? Now, I'm going to show you another visual of this. Everybody can see me in profile now, yes? Which is almost as gorgeous, but not quite. Profile. Agreed? My eyes are looking right out there. Everybody with me? There is the first line, yes? If I look up at the ceiling, whoop, the angle is where my face is, yes? Yeah? Between the horizontal and where my eyes ended up, yeah? Okay. Everybody gets that? All right. Well, now we need to talk about the angle of depression, which is also the angle of declination. Now, for some reason, everybody screws this up. We start with the eye. It looks horizontal. Agreed? Now, if the angle of elevation goes up, the angle of inclination goes up, where does the angle of declination go? Down. And where is the theta? In the middle. Right there is your angle of depression. Now, many of you should be looking at that and saying, I don't understand how that's a problem, Mr. Myers. I get it. When you look up, it's in between. When you look down, it's in between. It's pretty simple, isn't it? Right? So I'm going to go back to black over here, and I'll write the angle of depression is the angle between the horizontal and where you look down. Is everybody cool with that? Everybody understands it? Okay, now I'm going to draw something on a blank piece of paper. I don't want you to draw it. I just want you to look at it. Here's the problem with it. Building, yes? Everyone agrees? Easy peasy lemon squeezy, yeah? Okay. Myers. On top of building, yes? Cool? Okay. Annalise Vike. She's a girl, so she's in a skirt. Blonde hair. Hard to see. Going to orange. Annalise Vike. Oh, wait. Glasses. Everybody cool? Everybody cool? Annalise Vike walking down the street. Looking around, minding their own business, looks up. Holy crap, there's a good-looking dude on top of that building. Her eyes are looking this way because that's the way she is walking, yes? Agreed? Notice this good-looking dude on top of building. Eyes drawn to good-looking dude on top of building. Makes an angle of what? There is elevation. Does everyone understand that? Now here's the problem. Meyer's on top of building. Holy crap, is that one of my students? Where do my eyes start? This way. And then they go where? Down to kid. Where is the angle of depression? Is it A or B? It is B. No matter how many times I teach this, no matter how many demonstrations I do, no matter how I try to explain it, every year when it comes to the test, invariably half of the class tells me this is the angle of depression because they don't actually understand it. Now here's the next problem. What can you say about Annalise's angle of elevation and my angle of depression? Antonio? No. They are the same because they are on opposite sides of the transversal. Now, that's not part of grade 10 math, but it is something you need to make sense of. And that makes sense, doesn't it? If Annalise's eyes are looking horizontally and then come up to meet mine, and my eyes are looking horizontally and come down to meet hers, obviously they had to go the same amount of distance, yes? Now, what Antonio said, they got to add up to 90? Not quite. A and elevation have to add to 90 because this is 90. Okay? Does everybody see that? Because we have had this example in trig before, yes? Right? The opposite and adjacent depends on the angle from which you are starting, yes? So angle of elevation and angle of depression count for from whom you are starting, yes? Can Annalise do an angle of depression? Sure she could, because she notices a $20 bill on the ground. And even though there's a super handsome guy up here, where's her eye going to get drawn? To the $20 bill. Where is Annalise's angle of depression to the $20 bill? Is it X or Y? See, you all just did exactly what I said you were going to do. Her eyes started horizontal and moved down. So Annalise's angle of depression is the Y. You all just did exactly what I said you were going to do. Even though I just warned you.
I said Y.
Yeah, okay. So you're the exception that proved the rule, Mark. Huh? Plane flying overhead, pulling a banner that says math. Where do my eyes go? Up to plane. Where is my angle of elevation? It is right here, right? Pilot, looking down, good-looking dude on top of building. Where is his angle of depression? Q or R? R. Because his eye starts out there and then goes down to the good-looking man on top of the building. Do you understand? Okay? Everybody got it? It's the angle between the horizontal and where your eye ends up. All right? Cool? Okay. Grrr. Huh?
So why are you randomly standing on the roof?
Oh, I'm suntanning. I don't know. I'm taking care of my pigeons. I don't know. I'm on the roof. When I was a kid, the big challenge was to get on the roof of buildings. Didn't matter what the building was. Your goal was to get on the roof. Okay, I don't know if it's the same for you guys. You guys are too busy playing Call of Duty. But we didn't have video games. So we went out and we did stuff. And the number one thing was getting on the roof. And the number one building to get on the roof of was schools. If you could get on the roof of schools, you were cool. And there were various roofs of various schools around. And they were leveled for like, oh, I got on the roof of Osler. Oh, big deal. You just go up by that shelter by the gym. Oh, I got on the roof of Churchill. Shut up! That roof is impossible to get on. And it was quite difficult. The school, Churchill. Yeah. And then it became how many people it took to get there. Churchill was almost impossible to get on the roof because it was 3 floors, except you could do an Indiana Jones leap over this hallway because there was a raised field that was about 1.5 meters away from the roof. And if you climbed up onto the top of the chain link fence, you could jump over the hallway onto the roof. That was the pinnacle to get on the roof of Churchill. Haven't played Call of Duty once, but I can get on the roof. Huh? A school in Powell River. It's been bulldozed since. It's not there anymore. The gym is still there. It's the Powell River Gymnastics Club. And the industrial education wing is still there. It's modern windows and drapery. But the actual school has been bulldozed. All right, is everybody good? So, why was I hanging on the roof? Because I didn't want to play Call of Duty and I wanted to get on a roof. Because it was taking me back to my ute. Everybody good? All right. Now, all of that was recorded. So if your parents do happen to watch this with you because they need to learn Trig, please remind them, parents, I no longer go on the roof of schools for fun. And I am not espousing that your children go on the roof of schools for fun at any given moment. They should definitely continue to play Call of Duty. Everybody good? All right. Now. Oh, I don't know. Because it is. All right. Word problems for Trig. What do you need to do a Trig problem? A triangle. Does the triangle have to be perfect? Does the triangle have to be pretty? Does the triangle have to be to scale? No. All you need is a triangle. Done. Now let's label it. Ike is standing on a soccer field. Where is the soccer field? Up or on the ground? On the ground. You would not be surprised how many people put Ike floating in the air up here. Ike is down on the ground. Yeah? The school, which Ike wishes to get on the roof of, is over here. Ike looks at the roof of the school with an angle of elevation of 30. Where is the angle of elevation? Is it the top one or the bottom one? The bottom one, because Ike's eyes start down where his head is. Right? He is not a robot. His eyes do not go up here. They do not float up there and look around. They are here. Then he looked up to make an angle of 30 degrees. Ike is 42 meters away from the school. 42. How tall is the school? Well, what do I have? Do I have a theta? What is it? 30. What is 42 compared to 30? Adjacent. So I have an adjacent of 42. I need this guy, which is opposite. What uses O and A? Tan 30 is O, X, over A, 42. Number on the bottom, what math is it? Multiply or divide? Multiply. 42 tan 30 equals X, and then I use my calculator to find the answer. What is it?
14. It's 24 times.
Sounds about right. Sure. 24.2. Is everybody good? So all of you that are like, oh, Mr. Myers, Trig's so hard, draw a triangle. Just draw a triangle. That's all you got to do. Abby is flying in an airplane at 2,500 feet. So Abby is where? Up in the air. Airplane. Is the airplane a triangle? No. Make the triangle. It is up in the air at 2,500 feet. What direction is it flying? Horizontally. That way, yes? Agreed? Okay. Abby looks down at an angle of depression of 15 degrees. So Abby she's looking forward because she's flying that way. Then she looks down and sees the town of Mission. Where is the angle of depression? Is it X or Y? It is Y. There is my 15. Do I have a triangle yet? No, I have lines. Now I have a triangle. How long is this side if I know that the plane is 2,500 feet in the air? 2,500 feet. I want to know how far away horizontally is Mission. So I need this. Do I have a theta? What is it? 15. Do I have an adjacent? It is X. Opposite is 2,500. What do I need? Tan. 15 is opposite, 2,500 over X. When the letter is on the bottom, what do? Divide. 2,500 divided by tan 15 gets me X. And what is that answer? Sounds about right. 9,330. Okay? Now, guys, believe it or not, being able to do trigonometry is actually something that comes into play with flight. Winds, directions, northwest, southeast. This is where another use of it in real life. If you want to become a pilot, if you want to become a pilot, you and 20 of your friends, one person is smiling. She doesn't want to laugh because it will make her feel that she was the only one that got the joke. You and 20 of your friends want to become pilots. My favorite band right now, 21 Pilots.
I like that band.
Who doesn't? Crazy people. That's who. That band is awesome. If you don't know who 21 Pilots are, get a clue. For goodness sake, go see Suicide Squad. They sing Heathens. That's not even their good song. That's just okay. Anyway, that was my fun little joke. Thank you, the one person who laughed at it the first time. That person knows who that person is. Ooh, good gravy. What's happened here? There we go. All right. Now, turn the page, because I think you guys need to go to the next page now. No, you don't. You've got it right there. I need to go to the next page. For some reason, people cannot do this question, and this is the first question I like to let you try on your own. For some reason, people have a problem with this question because of the way it's worded. Remember, what do you need? A triangle. Try to do your work on the left in case you're totally wrong and you got to change it on the right, because I know a bunch of you don't do your work in pencil, so you can't erase it. I like this question because the math is not that complicated, but the question messes with kids' heads. Hey, Abresia, do you call fans of the group 21 Pilots passengers? Well, it might bother that horrible singer, Passenger. It's too bad about that guy. Because he has my favorite song ever for lyrics recently. Scare Away the Dark. Of course you know it, Mark, being a cool guy like you are. You don't know it? You should Google it. But don't listen to the song, because the song is very wussy and Passenger's the guy that sings that. Never know you're high when you're feeling low. Never know the road when you're missing home. Never know your lover till you let her go. And then you let her go. I just want to climb down the radio and punch him in the mouth. I just hate him so much. Of course you like that song. You're a girl. It's a horrible song. I'll let something go. A right cross across your nose. So that was his first song. And I was like, everybody loved it. It's like, oh, Pastor, he's such a genius. And I was like, oh my God, if I have to hear this song one more time, I'm going to deafen myself on purpose. And then his second song came out, which is called Scare Away the Dark. And it's still very wussy and lame, but the words are wicked awesome. And if you read the words, you'll be like, I don't agree with anything he's saying, but I totally understand why Myers thinks he's brilliant. Because you guys will be all like, I don't know what he's complaining about. No, because it's math class. But see what I did there? Some of you are going to go home and find out what Scare Away the Dark's lyrics are about. Some of you are going to do it right now on your phones. But that's okay. All right. So, this question. The road rises 1 meter for every 19 meters measured along the road. For some reason, that causes great trouble for people. So there's my triangle, yes? It rises 1 meter. Where's the rise? X, Y, or Z? X is the rise. So this is 1. For every 19 meters measured along the road, where is the 19? Is it X or Y? I think you guys should fight. Of course it's X, because we are measuring along the road. You cannot drive a car into a mountain, get to the middle of the mountain, and then drive straight up the mountain. So here is the 19. Now, do you have your triangle? Yes. But I want to know this triangle. I have driven 300 meters along the road. How do I find out this horizontal distance, which I'm going to call X? There are 2 ways to do it. You know how to do it from the 9th grade, or you can do it with Trig. Figure it out. There's also some, I re-showed you what you know in the 9th grade to solve that this year. Or you can use Trig. I'll give you a real big hint. That should help. See how I did that, Antonio? And it's almost perfect, hey? That's just dumb luck. It never works out that well. Usually when I move it over, it's all... Everyone's like, that didn't help at all. Shut up! Just going to move that back now. Yeah. You can talk to each other. You don't have to try this on your own. Talk amongst yourselves. Everybody turns to Antonio. So how am I going to solve this? Who has a way to start? You might not have the right answer, but how are you going to start? Antonio?
I would want to find the bottom length of the first column.
You would want to find this x right here, yeah? And how would you find that? You would use Pythagoras. So this is the square root of 19 squared minus 1, yes? Right? Everyone agrees? No. 19 squared is 361. Minus 1 is 360. So this is the square root of 360. Does everyone agree? No, just trust me. Let's just leave it as root 360. Then we don't have to do any rounding, yeah? So this is root 360, yes? Which means if I use my grade 9 knowledge, 300 over 19, because you can compare hypotenuses, because these are similar triangles, is the same as x over the square root of 360. And then you cross multiply, yes? 300 times root 360 divided by 19. And you would get 300 times root 360 divided by 19. 299.6. Everybody cool? That's what you learned in grade 9. Some of you may not remember it, but I can point at 5 people in this room that definitely know how to do that question that way because they were in my grade 9 class. Everybody cool? Now, could you have done it with trig? I'm going to erase this. Could you have done it with trig? Yes, because this angle theta right here would be the same in here, wouldn't it? So if you use shift sine of 1 over 19 to get theta, can't you do shift cos here to get x with that hypotenuse? Because it's going to be the same angle, isn't it? So if I do shift sine of 119, or 1/19th, I get 3.016 degrees. Then a bunch more decimals, right? So now I have theta, I have an adjacent and a hypotenuse, cos, not shift cos, cos of 3.016 equals adjacent, x, over 300. So if I do 300 times cos 3.016, I will get, again, 299.6. Is everybody with me? Why would I give you that question there that has more than one way to do it that early in the game? Because I need you guys to see that every single math tool you have ever been given is available to you now. You needn't always use the thing that we are studying right then, right? Pythagoras you learned in grade 6. Similar triangles you learned at some time between grade 6 or grade up to grade 9. And you could do this whole problem without ever touching trig in grade 10. But it's still a trig problem, isn't it? And again, this is another real life use. When do we use stuff like this? How many of you guys watch CSI shows where they show a car crash, then they take a bunch of measurements and they say the car was traveling this fast in this direction? What math do you think that is? Trig. And then you can go be a CSI, because since all those stupid shows came out, it's become the number one desired profession for kids in North America, to be some kind of CSI person, because the TV shows make it look very glamorous. It's not. You're wading in blood one time out of 100. The rest of the time you're sitting at a computer doing math. Awesome. Anyway, now if you want to be a CSI, by all means go ahead and do it. Don't let me stop you. I'm just saying, don't think it's like the movies. Okay? There won't be that woman that shows up at the office in a tank top with her breasts hanging out like they do on the TV show. Because you're allowed to show up at work dressed that way, aren't you? No. I hate it. And girls, they are not all going to look like superhero cops. Some of them are going to be fat with mustaches and donut dust in their hair of their mustache. Okay? They are not all going to look like, I can't think of a super good looking dude on TV right now. That's stupid of me. Why can't I think of one that's a cop? Channing Tatum. They're not going to look like Channing Tatum. All right? Just like all your math teachers aren't going to look like this. All right. Let's do the next one. Actually, I'm done. You guys go ahead. I want you, how many questions you got left in that before you get to the next thing? Should go up to about number 15. Goes up to 20? Okay. Okay, listen. Up to 20 is your homework. All right? If you look on the outline, you notice that I have given you some textbook work as well. That textbook work has the right answers, yes? Some of them are sine, some of them are cos, some of them are tan, and some of them, it's a sheet that has all three, and you got to choose which one to use. Okay? Everybody with me? By the end of tomorrow, I want those 20 questions and these done. By the end of tomorrow's class. Do you understand what I'm saying? So you can do as much or as little tonight as you want and right now as you want, as long as by the end of tomorrow, the next few questions in the book are done and these. Now, if I were you, I would start with these because these have the answers in the back of the book and you check, make sure you're doing it right before you go on to the stuff in your notes because your notes don't have the right answers. Follow me? Everybody good? But I'm thinking maybe I should do one more question here. Maybe we should do this one. Let's do this one and then I'll shut up. Maybe I should do 4 and 5. I can. I don't care. It doesn't bother me. I love doing trig. What worries me is that if I continue to talk for another 30 minutes. Yeah. One of these with a shape and one of the words? Sure. We'll do it that way. All right. So I'm actually going to skip number 4. I'm going to let you guys figure out number 4 because you do know it. I'm going to go to number 5 for me, which I think is number 11 for you. 13. Okay. Remember, before you even start, you should know where you're going, right? You don't get in your car, start it, and just start driving aimlessly. You have a place you're going, yes? So, but no, because you still have a reason. You're driving somewhere. But you're driving somewhere, right? If you weren't driving somewhere, you would have sat in your house. So the point is to get in your car and drive somewhere. You don't get out and drive around the block and come home and say, good Sunday drive, right? Okay, so you got to know where you're going. So this question is saying, find the length of MN. which is right here, correct? So that's my ultimate goal. So if I'm going to find MN, I need to use this triangle, yes? And to use that blue triangle, to do trig, I need at least what? I need one more side, because I need at least two sides or an angle and a side, yes? I have an angle, so if I can find one more side, I'm good here, yes? Which side can I find? LN I can find. Why? Because this triangle has an angle and a side. So I can use those to find this, yes? So how do I do that? Well, in the purple triangle, do I have a theta? What is it? 33. What else do I have? I have an hypotenuse of 8.2. What do I need? An adjacent. My adjacent is LN, right? Now, in grade 10, we like to name that properly, and since it's opposite of K, it's little k. Everybody cool with that? Anybody got a problem? So, cos of 33 is little k over 8.2, yeah? So little k is 8.2 times cos 33. Now, have I touched my calculator yet? No. Why? Why do you think I've gone to here and not touched my calculator? Because I can do that in my head, can't I? Right? I know that it's 8.2, I know cos 33, and I know that I got to multiply there, right? Now, if I go to my calculator, I'm going to get it decimal, aren't I? And what are you guys automatically going to do? One of two things. You're going to round that off, which is fine in math class. Is that okay in reality? If I round stuff off in the real world and I send a rocket to Pluto, is it going to make it? No. So that's one reason I'm not going to go to my calculator yet, because I don't want to round now because I've got further calculations to do, don't I? Second thing I'm going to do is I'm going to hit clear and forget what it was, and then forget that Mr. Myers has taught me that the ANS button will bring that back. So I'm going to get screwed if I go to my calculator now, right? But I know that this side is this value, don't I? Everybody with me? Now go to the blue triangle. What do I have? Do I have a theta? 49. Do I have a hypotenuse? It's this, isn't it? 8.2 cos 33. And I need this side, right? Which is what? From 49. O or A? O. My O, and that side little l, isn't it? Because it's across from big L. Everybody with me? What uses O and H? Sine. So sine 49 equals O, which is little l, over 8.2 cos 33. Since the thing I know is on the bottom, what do I do with these two? Multiply. So I got to do 8.2 cos 33 times sine 49. And that will get me L. Now, if I go to my calculator, do I get one answer? Yes. And that is where I can round. Do I insist that you do it this way? Do you think? Or am I perfectly happy if you go to your calculator here? What do you think I would prefer? What gives me the best possible answer? This, which is circled in green, or this, and then moving this rounded number to there. The green is the best. That causes a lot of you concern. You don't like leaving this written this way. Just like you didn't like doing the first unit, leaving pi as pi, did you? You all needed a number there. It's got to be a number. I can't say 100 pi. It has to be 314.16, Mr. Myers. can be 100 pi. And this can be 8.2 cos 33. Now to do that on your calculator, what are you going to punch in? 8.2 times cos 33 times sine 49 equals. And you're going to get the right answer. Are you all with me? I don't like going to my calculator more than I need to because I have fat sausage fingers. I hit the wrong button all the time. So why would I use my calculator to do something that I don't even need it to do? Because I know this is how long k is, don't I? I don't need the number until over here. Do you understand what I'm saying? Everybody cool? Everybody good? Now just to prove it, watch. I'm going to do this right now. 8.2 cos 33. Oh, crap. If you have a backwards calculator, you just reverse the coses. So it's 8.2 times 33 cos times 49 sine equals 33 cos sine 49. 5.2. Everybody cool? Everybody see? Now, if I could do it the way you guys originally wanted to do it, I got to go 8.2 cos 33 and round that off to 6 point. You guys would probably use 6.9, yeah? Everyone agree? Okay. So this is now 6.9. So this is now 6.9. So I can go to my calculator and go 6.9 sine 49 and get 5.207. I had 5.199 before, didn't I? You're both going to round that to 5.2, yeah? So either way works. But again, I call your attention to which one is a more exact answer. The 5.19, yeah? That's all I'm saying. Some people, especially Sammy, if they have backwards calculators, don't like to do extra trig because there's a chance to screw it up. So I give you this option to leave it all written this way until the end. If you want, it is totally up to you to choose how you wish to attack your trig questions. Okay? This is just something else you can do. With the warning that as you go further and further into math, just like the pi has stopped being 3.14, cos 33 will stop being point blah, 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 blah. Because it's not exact, is it? It goes on forever, right? Those decimals. But cos 33 ends right there. So if you're doing higher level math, you're going to leave it written as cos 33. So you don't have to do any rounding. All right? Because you guys have all been in the math class where you've been talking to your teacher. Well, it's all right if I went to 4 decimal places. Yes, it's fine. Understand? So this option is available to you. I don't care which one you use. Everybody cool? All right. Now, Sammy said I should then skip to a one-word problem, which I don't mind doing. Let's go to, it should be number probably 16 for you guys. The tower supported by the guy wires. What is it? 16? Okay. I need a triangle, yes? Right? So let's draw it. There's a tower. It's got 2 wires. The wires are anchored to the same point in the ground, 8 meters from the tower. So that's 8, yes? There's 2 wires. There's a longer one and a shorter one. So a long one, let's put it all the way up to the top. The shorter one, let's put it up there. Which is which? The longer guy wire is 56. That's the bigger angle, yes? So that is here, 56. The shorter one is 32, yes? So what do I really have? I have this triangle, 56 and 8, and I have this triangle, 32 and 8, don't I? Yeah?
Oh, it's the same law. Thanks.
The question is, determine how much wire I need to build this situation. So I need this wire, X, and this wire, Y. And then what am I going to do with X and Y at the end of the question? Add them together. Okay? Now, Sammy, I understand you're saying I should do a word problem, but from here, you guys should be able to handle this, yeah? Because do I have a theta here? What is it? 56, and I have an adjacent of 8, and I need a hypotenuse, yes? Do I have a theta here? What is it? Theta 32. I have an adjacent of 8, and I need a hypotenuse. And then what am I going to do with hypotenuse 1 and hypotenuse 2? Add them together. Hypotenuse 1 plus hypotenuse 2 equals. Okay? Now I want to give you guys a few warnings before I let you go. Triangles can be split up, right? Just like the road problem, right? I could have drawn it as two triangles, split them up. Same thing here, right? When you get to these questions, for example, this question right here, this question is very fun. Because what do you really have there? You got two triangles, don't you? So, 1 second, Antonio, hold it in your head. Remember that you can redraw this as 6, 9, 90, and 6. And then the only part of that you know is 4, right? But you know this part in here is the same as that, yes? Everybody picking up what I'm putting down? Okay, Antonio.
I don't get what you actually what you have to find out. So what angle?
Do I need to review how to read angles with people?
Oh, I think it's the angle at 8.
When you have all three letters, you go point to point to point. So I start at G, I go G to H, and then I go H to J. So I need this whole angle, which when I split it up is this one. Okay, does everybody remember that from grade 9? How to read that kind of angle when it's written that way? Just like in grade 9, you would have said this side was HJ or JH, yeah? Unless you were in my class when I gave you the heads up and told you, well, really, we're going to be calling that little g next year, right? Everybody cool? Okay, so everyone's feeling semi-good? Please remember, all trig is the same. It's just a different permutation of what you already know. SOHCAHTOA gets you through everything. Sometimes you got to reach back into your math toolkit and grab Pythagoras, pull him out kicking and screaming by his hair. He's Greek, so it's long. Nothing? I don't even know why I try. Next week, no more comedy, just math. Then we'll see what happens to my videos on YouTube. They'll switch back. Education. All right, so we know what we're doing? The rest of these problems and some of those word problems. Now, I recognize that a great many of you aren't going to bother doing all that work before the end of tomorrow. I know that. I'm not stupid. Okay? But I will warn you again. If you do not practice, you will not do well. If you care about doing well, you must practice. I do not understand how you can do 2 or 3 trig questions and not be able to do a third one, because it's the same stuff. For some of you, it's almost like you've done nothing with trig at each question. You're coming to it like you know nothing. I don't know how to fix that. It boggles my mind. Okay? Just remember, it's exactly the same as the question before. Make a triangle, find your theta, write what you know, and choose sine, cos, or tan. If the unknown's on the bottom, divide. If the unknown's on the top, multiply. That's all of trig. Okay? Go.